Okay, good day, everybody. Okay, today we're going to be looking at physics, and the topic is linear motion. So, talking about linear motion, we have different types of motions. We have the circular motion, rotational motion, oscillatory motion, which can also be called vibratory motion. We also have random motion, and we also have translational motion, which can also be referred to as what? Linear motion. Um, Today we're going to be specifically talking about linear motion. Linear motion is actually what? A motion on a straight path, movement on a straight path, where we're looking at one dimension um, movement, one dimension movement. Example could be a car moving on a what? Straight path. Okay, looking at what we have on the board, equations of linear motion. Now we're going to be working with this equation. Number one, we have v is equals to u plus at. Now what is v? V is actually what? Final velocity. What is u? U is what? Initial velocity. What is a? A is what? Acceleration. And what is t? T means what? Time. Now, this equation can be changed to become this, where you have v is equals to u plus gt. You can see the acceleration changes towards g, that's acceleration due to gravity. Now, the difference between these two is that this is applicable to linear motion on a straight path, which can be likened to be what? Horizontal movement. And this can be likened to also linear motion on a what? Vertical what? Path. When you have a body either going upward or what? Coming downward on a what? Vertical path. That's where you have what? The G. Now, if a body is going upward, the G becomes what? Negative. But if a body is coming down, the G is what? Positive. Why is it negative? Because when a body is going up, it is going against gravity. So the G is always what? Negative. But when a body is coming down, it's obeying the laws of what? Gravity. The G is always what? Positive. Now looking at equation 2, we have v squared is equals to u squared plus 2as. Now of course we all know by now that v means what? Final velocity, u means what? Initial velocity, the a means what? Acceleration, and the s here means what? Distance. Now it becomes, when we're talking about free fall of a body, either going up or coming down, this formula becomes v squared is equals to u squared plus 2gh. You can see that the x becomes h, it turns to height. Hope you're capturing the board so that you can see very well. The x becomes h, and the a then becomes g because it's with respect to gravity. Okay, now we have number 3, we have x is equals to ut plus 1 over 2 at squared, where x here is what? Distance, u here is initial velocity, t here is time, plus 1 over 2, a here is what? Acceleration, and this other t is what? Time. It also becomes this when you're dealing with what? Vertical movement. So the s becomes h, the u remains in its form, the t is still there, which is time, and you have plus 1 over 2 g t raised to power 2. Now the acceleration becomes what? Gravity. Now note, before you start using this to solve, there are some things you need to note, and it's just here. Please, can you come closer so that they have this view? Now note, a body starts from rest or accelerates from rest. The initial velocity is 0. What that means, if you have a car that is starting from rest, you enter into the car, you start the ignition and you're moving. The moment you start moving, that initial velocity you start moving is regarded at that point where the car is at rest is regarded as what zero because the car is parked, the body is at rest. Is regarded that the initial velocity is what zero. Now number two says a body accelerates to rest means final velocity is zero. It's very, very important to also take note of that. When the body accelerates to rest, when the body is moving or a car moving and later went to park, the moment that car parked, the final velocity is what? Zero. Now, number three says when the body is thrown vertically upwards, the final velocity is zero. Now, if I throw this marker upward, the moment the marker got to this point, at this point, this final velocity is regarded as zero before it starts coming what? Downward. That's what we are saying here, that when the body is thrown vertically upwards, the final velocity what? Is zero. And velocity is also zero at maximum height. That's what I'm explaining when I throw this upward. At this point, this is regarded as the maximum height before this thing or this marker starts falling down. So when I throw this, it's going with a velocity. But when it comes to this point, it came with initial velocity. When it comes to this point, before falling, the final velocity here is regarded as zero before it starts falling down. Now let's go straight to the questions we have on the board. Now, when solving questions under linear motion, you will need to read the questions, interpret the questions, and then you look forward to the formula that you need to infuse in solving this question. Question number one says a body starts from rest and accelerates uniformly at 5 meters per second square until it attains until it attains a velocity of 25 meter per second. Now it says calculate the time taken to attain this velocity. Now looking at what we have in question number one, we need to analyze it by looking critically on words and what is mentioned in that question. We write it down and we start solving. Solution. Solution to question number one. It says a body starts from rest, which means when the body starts from rest, the initial velocity, according to what I read on the note number one, the initial velocity is what? Zero. Okay. You see, a body starts from rest and accelerates uniformly at 5 meters per second. So acceleration here is 5 meter per second square. Now, until it attains a velocity of 25 meters per second. So, velocity is what? 25 meter per second. Now, they said calculate the time taken to attain this velocity. Now, we're looking for time. So, they said we should calculate time. Now, from this, you could see that the only formula that has initial velocity, acceleration, final velocity, and time is formula number one or equation number one. So we're going to be applying this equation to solve this. But why slotting in all these parameters, we are to make t to stand alone. Straight, we go v is equals to u plus at. Now our final velocity v is what? 25 is equal to initial velocity, since it starts from rest, is 0, plus acceleration is what? 5, and then we have our time t, which we are looking for. Now, since this is 0, is up, so we have 25 is equals to 5t. Now, for we to find t, for t to stand alone, what do? We divide both sides by the coefficient of the time. So divide both sides by 5. Now, 5 will take out this 5. So time will be equal to 25 divided by 5 will give you what? 5. So the time is what? 5 seconds. So that is our what? answer for question number 1. Quickly, we're going to be doing question number 2. Question number 2. Hope you've captured this. Thank you. Question number 2. We have um, we have a body accelerates uniformly from rest at 2 meters per second. Calculate its velocity when when it has traveled a distance of 9 meters. Now let's look at all the parameters we have there. Question number 2, we have the body accelerates uniformly from rest, which means acceleration is equals to 2 meters per second square. That's what acceleration is. It says calculate its velocity. Calculate its velocity when it has traveled a distance of 9 meters. So final velocity is what we are looking for, but distance x is what 9 meters. But remember, there is a statement there. They said a body accelerates uniformly from rest. So which means the initial velocity is what? 0. Now let's go back to the equations of linear motion. Which of these formula has acceleration, velocity, distance, and initial velocity? You could see that is no other formula than what equation of linear motion number what? 2, that has velocity, initial velocity, and acceleration and what? Distance. So we're going to use the equation number 2. So applying equation number 2, we have v squared equals to u squared plus 2ax. Now, final velocity is what we are looking for. We still maintain it. The initial velocity is 0 because it's starting from rest, plus 2. Then acceleration is what? 2. So we have times 2. The distance x is what? 9. So we have v squared is equals to 0 raised to power 2 is 0, plus 2 times 2 is what? 4. 4 times 9 is what? 36. Now we have v squared is equals to 36. Now square root, remember we are looking for v, not v squared. So square root both sides. So v square will take out this 2. Now the square root will take out this 2. So v is now alone. So square root of 36 is what? 6 meters per second. So that's our final velocity. Now quickly we're going to do question. Are we good? Okay, question number 3. A car starts from rest and cover a distance of 40 meters in 10 seconds. It says calculate the magnitude of its what? Calculate the magnitude of heat acceleration. Now let's also analyze question number 3. It says a car starts from rest. Whenever a car starts from rest, its initial velocity is always 0. That covers a distance of 40 meters. So distance is what? 40 m. In 10 seconds, so time is what? 10 seconds. Let's calculate the magnitude of acceleration. So acceleration is what we are looking for. Now, let's go back to the equation of linear motion. So we still have our 3 equations. Now, which of these equations has initial velocity, distance, time, and acceleration? You could see clearly that is equation 3. So we're going to be using this formula for equation 3. So we have x is equals to ut plus 1 over 2 at raised to power 2. Now what is our x? Our x is 40. We're going to write 40 there. Remember, initial velocity is 0 because it's starting from where? So 0 times time is 0 plus 1 over 2. Our a, which is acceleration, is what we are looking for. Then time, t, which is what? 10 seconds. So we'll square it because there's square on it. So we have 40 is equals to 0 times time. Here is 0 plus 1 over 2a. Now 10 raised power 2 is what? 100. So remember, this becomes 40 is equals to this 0 is off. So you have 1 over 2 times 100 in. Now 2 here is what? 1. 2 in 100 is what? 50. So we have 40 is equals to 50 a. Now to find acceleration, we divide both sides by what? 50. We divide both sides by 50. 50 will take out this. Then let's take the 0. So A is equals to 4 all over what? 5 meter per second square. Now you can decide to also convert this to a decimal. So when you do 4 divided by 5, you get your answer in decimal. Now let's go straight to the last question. The last question says a car moves with a speed of 30 meter per second. It says calculate the distance traveled. I think this is straightforward. Calculate the distance traveled in 30 seconds. So what are those parameters we have there? A car moves with a speed. So which means speed S, we have speed here is equals to 30 meter per second. And then we have time to be equal to 30 seconds. Now they said we should calculate the distance. So distance is what we are looking for. Now we all are aware of this formula. Let me write this formula. Speed is equals to distance over time. So this is the formula we're going to use. I had to bring this just to create a different mindset on this formula, the different from what the equation. So speed is what? 30. We're going to substitute 30 in place of speed. And then we have distance all over. And our time is what? 30 what? 30 what? Seconds. So to make distance to stand alone, you put 1 here, you cross multiply. 1 times is the distance and 30 times is 30. So 1 times distance is still distance. Then on the other hand, you have 30 multiplied by 30. So distance is equal 30 multiplied by 30 will give us what? 900 meters. So that becomes our answer for what? The distance. Now, I'm going to be giving you this assignment. Please kindly take note of the assignment. You do it, you do the assignment, and you submit it on the comment section of this video or on the WhatsApp group that this video will be dropped on. The link will be dropped on. Thank you. Till we meet again next time. Remember to subscribe to this channel, like the video, comment, and share. God bless you as we see in the next video.